Homework 2.6, combinations of functions, video 4. Homework due Friday, May 22nd, 2020 at 11:59 p.m. We're still talking about combining functions with addition, subtraction, multiplication, and division. And so we're still focusing on homework questions 9, 10, and 11. In fact, you may be thinking this is exactly the same as the previous video's contents, but look just a little more closely. I did change the functions. Notice one of them is not a polynomial function, but rather a square root function. So right out the gate, we've got domain issues. The reason I wanted to do this one was to show you that sometimes uglier is better. This function is a little uglier than just a polynomial, but that's going to make things easier for several of these functions. For example, when we add f plus g of x, when we calculate f plus g of x by adding f of x and g of x, there's f of x, the square root of x, there's g of x, x minus 5, and we're adding them. What can we combine? Nothing. There are no like terms. So the minute we set it up, it's done. That's good. However, we do have domain issues. We do have a square root, and remember, to find the domain of the square root function, you have to solve the radicand, which is just x, greater than or equal to 0. Well, I should put quotes around the word solve because it's over as soon as it starts. It's already solved. And so our domain is everything greater than or equal to 0. Let's not mess with the number line and just go ahead and write it as bracket 0, comma, infinity, close parentheses. Well, that was quick. What about subtraction? To find f minus g of x, write the first function, so the square root of x, minus the second function, which needs to go in parentheses if you're subtracting. In case you were wondering why I didn't put parentheses in the addition problem, it's because it was an addition problem. So now we need to see what we can do with the square root of x minus the quantity x minus 5. But as with any subtraction problem involving polynomials or variables in general, you should always ask yourself, do I need to distribute the negative? And the answer is yes, if there are multiple terms. So the square root of x would stay put, the x would become negative x, and the negative 5 would become positive 5. But just like the sum above it, there are no like terms, so this one is over. And it has the exact same domain issues. Its domain is from 0 to infinity, including the 0. What about multiplication? Well, let's multiply the square root of x times x minus 5. Could you distribute this? You could, but I'll tell you right now, the homework will accept that answer because distributing it really isn't going to give you anything unless we go off into rational exponents, but since we didn't talk about those in a previous opportunity, I'm waiting until we get to logarithms. Then we just won't go down that path right now. This is a perfectly acceptable answer for the product of the two functions. And like the two functions above it, the domain is still the same. So again, you can see that one of the functions having a square root and the other one being a polynomial makes a lot of these easy. Two of them ended the minute they started. The subtraction had a little cleanup. And they all have the same domains. But anytime you create the quotient of two functions by a division problem, you have new domain issues. Well, you probably have new domain issues. Because if we put the first function on top, the square root of x, and the second function on the bottom, x minus 5, the square root still has the exact same issues it had before, but now we have to incorporate the denominator's issue, and we can't let the denominator equal 5. So how are we going to write the domain to say it's this, but not including 5? Well, without writing the number line, let's just start with the domain was before we had the denominator issue. It started at 0 and it went all the way to infinity. But now because of the new denominator, we have to stop at 5 and exclude it, which means parentheses. Now, that's not the domain because there's a lot of numbers missing. Remember, prior to the denominator, I could put in anything 0 or greater, and right now I just have 0 through 5, but not including the 5. I have to set up a union and open up an interval to pick up every number after 5, both the 5 and the infinity getting parentheses. So as you can tell, combining functions sometimes takes a little bit of work and sometimes doesn't. But since you're going to be asked to create 4 functions and their domains, then get ready, especially with the domains.